If not, why, either I'm blind or I've got too dark of sunglasses on. So, anyway, you know, I'm fond of saying that growing good wheat is more complicated than assembling and launching a rocket to the moon. And I think that is true, and I hope maybe as we get into this you'll see that indeed that's true. Now, I said good wheat. Now, anybody could grow some 30 bushel wheat. I could do that myself, but we're talking about good wheat, consistent wheat. That takes a little bit more skill. And for the guys who are doing that, there are three principles that I think they're following. First of all, they're learning about their varieties. And Paul mentioned a lot of the characteristics about varieties. I hope you are paying attention. Randy's handout is excellent. I use that every year and looking at and evaluating varieties. So variety is critical to your to growing good wheat. The second thing that I think is important is managing wheat development. And what do I mean by managing wheat development? I'm talking about putting tillers on this thing. You know, we're not planting enough seed to make a good yield here. If you're planting 22, 25 seeds per row foot, something around that area, you don't have near enough heads to make an 80 bushel wheat crop. You want that wheat to develop further heads in that crop, not just any head, but a big head. And that means that wheat has to have the time and the development potential to do that. And so that it's critical that that happens. So when we talk about wheat, well, you're asking what's the third factor? Well, the third factor is protecting that seed, whether it's a fungicide or anything to keep that seed filling as long as possible. Many of you know that wheat doesn't like it when we get into 90, 100 degree days. It tends to shut down in late May and early senesce. We don't like that. We want it to continue to photosynthesize, build that kernel weight. So that's the third factor to make it good wheat. I want to put, and actually both of these tests are focused on these last two factors. One on wheat development. What differences are there in development at different planting dates and different treatments, and can we manage wheat development? To some extent, I think we can. And then the test over there that we're not going to have time to talk about is really looking at trying to find ways to extend that green leaf area for as long as possible, managing that kernel fill and keeping good healthy leaves late into the season here. So let's talk about wheat development here for just a second. What controls wheat development? How do we control how many tillers we get here? Well, it all comes down to how fast these leaves appear on this plant. Once we start seeding it, the little coleoptile comes up above the ground and it starts producing leaves. How fast those leaves are developed has a big influence on how our yield happens. And there are several factors that influence leaf development. Probably the primary one is temperature, and you'll see that in a second. Nutrients certainly have a role in that. We can control how fast these leaves develop if we have yellow wheat, that's going to tend to slow wheat development. And then, of course, light. And not just amount of light, but the quality of light and the day length has some impact on the rate of leaf development. And here's some factors on the bottom here. Seeding rate, nitrogen, these are things that we found that have had an influence on leaf development rates here. Let's take a quick look at what leaf development looks like when I talk about leaf development. Here's a good example from last year. Here on this bottom axis I have growing degree days. That's temperature. That's a temperature above 32 degrees. And typically we'd like to cut off wheat development in the range of 79 or 80 degrees. Now it's hotter than that here today. This wheat's not moving a lot when it gets real hot. And like I said, if it gets into the 90s, it's thinking about shutting down. So that's the temperature range that's going into this calculation of growing degree days. And then we've got two planting dates here. The green little line there is November 12th. And that line, the slope of that line, represents the rate at which those leaves appeared. How many growing degree units did it take to put on another leaf on that plant? The red line is December 4th. Now, which wheat's growing at a faster rate? December 4th or November 12th? The steeper the line, the faster it grows. So it's certainly surprising, doesn't it? Surprises you that December wheat leaves would appear faster than they do in November. And you'll see in a second here, in fact, I'll just pick this chart up that Joseph's been taking data on here. Here's what it looks like this year. Did you think that leaves would develop in December planted faster this year? They're about the same. A slight difference there right there. The fact of the matter is light quality has an influence on how fast those are day length sensitive, that wheat tends to want to speed up as those day lengths change and that light quality changes. So as we plant later, that's a good thing. The wheat tries to develop leaves quicker here. Now, does that have an influence on what yield we get? Well, here's what we had last year. Here's the number of tillers we had at harvest. There's the December over here and the November over here. And indeed, we had more leaves. We improved our how much light we intercepted. We made more tillers. We kept more tillers on that crop all the way through to harvest here. And then finally, at harvest, did it make any difference in yield? Indeed, it did. It made a difference in yield. Now, let's take a quick look right here, because you can see what we're, like I said, from the trailer, what development has gone on this year, can't you? Here's what was planted on October the 21st, and here is what was planted on November the 15th. Which of those you think, this isn't as hard as that thing that Randy had us do, by the way. Which of these do you think is going to yield more? The October or the November wheat? October, hands down, isn't it? There's no chance that I'm going to get that same response this year, is there? What's the difference? The leaves are developing faster as I get heat. What's the missing element in that equation then? It's how much heat I got, isn't it? When I planted in October, I had some warm days in November I could count on, and we took advantage of those. When I planted in December, we ran out of warm days pretty fast, and it set for a long time. As you can see, both developmentally and even size-wise, we didn't elongate those internodes very well. So indeed, this is what's complicated about managing wheat. There are some years where you get a situation where you can plant a little later. You got some warm days in January. That wheat's going to develop quicker planted later, so it makes up the difference and actually yields better. Most years probably more like this year, where planting late you just run out of that amount of heat, that days of warm temperature to make that development here. I'm going to ask Joe here to talk a little bit about some other things that we're seeing as far as influencing the development rate. He's going to talk a little bit about what he's got here, and about what he's seeing as far as treatments and how they're influencing. Joe?
All right, well, as he said, we have two different planting dates here. We have the October 21st, which would be about a normal planting date around here, and then the November 15th, which, as you know, would be a later planting date. And basically we were just going through and counting leaf numbers, you know, seeing how fast the early growth period is, the phyllocrine interval, and just to try to determine which one was better, and if there was any difference between the two planting dates, and then how that impacted tillering and then a yield. And we also, within the planting dates, we have different starter fertilizer solutions with all the same amount of nitrogen, but we're looking at the impact of phosphorus and potassium, seeing if those had any impact on the phyllocrine interval. We have, if you look over here, we have our untreated control. We have 30% UAN. We have 11-37-0, and then 9-18-9. And then down here in the late planting, we have the same four treatments: the untreated check, and then the three different starter fertilizer solutions. So this is just a chart showing the phyllocrine interval, as we mentioned earlier, for this location. Like you said, last year we saw some differences with the later planting growing faster. Well, this year, as you see, this chart is basically on your whites here is phyllocrine interval, which is how many growing degree days it takes to plant to put on a new leaf. So actually with this, shorter is better. Don't let that confuse you, because the shorter it is, the faster it's putting on new leaves. It's taking fewer growing degree days to put on a new leaf. And as we saw in that other graph, and as you see here, there's not a whole lot of difference statistically between the two planting dates. And you do, but when we go into our starter fertilizer solutions at this first planting date, not a lot of the difference either. They're all about the same. However, when it gets later, there was some some stress, you know, it got a lot colder, so you did pick up a little response with your 11:37.0, your 9:18.9. That was shortening the phylloxera interval, so your plant was in fact putting on leaves a little bit quicker. Let me see. Okay. All right. Okay, this is the same study. It was done this year as well out at Plymouth, which is on the east, out toward the eastern coast. And as you see, you have a more distinct difference between your, well, among your 4 starter solutions. It was a lot colder and wet in December. You had more nutrient leaching. So therefore, in your later planting, your starter fertilizer, it had a more profound impact on shortening the phylloxera interval, and therefore you were putting on leaves quicker. So,
as you can see by Joseph's test here, it's hard to manage that phylloxera interval with starter. We thought that we could use some of these treatments, make up some of that difference in planting date, and you can see right there we struggled to do that. So what's the bottom line? You know, I said we were going to try to help you determine how to grow wheat better. What's the one thing that you could take away from this test right here that says to you, how do I grow good wheat? What one thing would you want to do every year to grow good wheat? Planting date. That's exactly right. Plant it right. Plant on the right time is going to be as much impact on your wheat crop as anything else you do. Now, how can you determine whether or not it's a good time to plant earlier or later? You know, sometimes 2 years ago, planting early, all we had was a lot of big leaves and a lot of disease in this crop. Well, what we're doing, and Joseph's working on this, is actually looking at climate patterns, trying to see, you know, sometimes you can use things like La Nina, El Nino to predict planting dates on corn. We're looking at that same thing on wheat, trying to use INSO periods or other indicators to say, well, it's going to be a cold fall, so I need to plant earlier. It's going to be a warmer December. I can plant a little later. And so far, he's got some interesting data. I hope next year at this talk we can talk a little bit about some of those patterns and help you become your own predictor when that best date is. But it's clear that that date is very important, and it's very difficult for us to manage a recovery in this wheat following that planting date. Any questions on this? I don't have time to talk a lot, but I would take a few questions if anybody's brave enough to venture one. Well, good. Randy, I got it under 15.